This concept activity helps you focus on the big picture of limits and how they help us with the graphs of functions. Oftentimes, whenever we're just focused on WebAssign problems, we tend to get lost in the trees. So hopefully this will help you take a step back and see what's really going on. A few people have emailed me asking for an example of a problem similar to the one on the concept activity. So I've came up with an example that is kind of similar to what you're given, or at least the conditions are similar to what you're given. And I'll come up with a graph of my own function. So how I go about doing this is I take the easiest things for me first. So that would be these points on my functions. I know that my function has a point at 0, 8. So I'll go ahead and draw that guy. And then at 5, 2. So I'll draw that point too. So that I have already done those two properties of my function. The next thing I want to do is I want to figure out where my asymptotes are. So if we'll start with the horizontal asymptotes, we know that if your outputs are approaching a number as your inputs are approaching infinity, plus or minus infinity, then you'll have a horizontal asymptote. And that's just by the definition that we were given earlier about horizontal asymptotes. So I'll look through these properties and see if any of those limits describe that. It looks like this limit has my outputs tending towards a number, 3, as my inputs are tending towards positive infinity. So let's go ahead and draw this asymptote on my graph. I draw it with a dotted line so I'm not confused later that this is part of my graph. The other thing that I do before I go on to another property that's given is I go ahead and sketch how this property is stated. So it says as x approaches positive infinity, my function tends towards 3. So that means I could either tend towards 3 for values that are smaller than 3, or it can come from above 3. So I know my function is either one of these two guys, either here or here. But I can make the decision which one I want later. I'll leave them both for now. So I've considered that property. It doesn't look like I have any other horizontal asymptotes, since the only limit that has my inputs approaching an infinity, plus or minus infinity, the outputs are also approaching plus or minus infinity. So this limit does not describe a horizontal asymptote. So let's move on to vertical asymptotes. For vertical asymptotes, your output values have to approach a plus or minus infinity as your inputs approach a number. So looking on these conditions, it looks like I have two limits satisfying that. They're also both approaching -2, so that I know there is a vertical asymptote at the line x is equal to -2. So I go ahead and draw it in. And then I'll go ahead and draw my tails too, so that I can just connect the dots later. As I approach -2 from the right side, my outputs are tending towards positive infinity. So I know this guy is on my function. And then as my inputs are approaching -2 from the left-hand side, my outputs were tending to negative infinity. So I have that guy. next thing I'll do is I'll deal with this limit, which talks about the end behavior. Functions where x is approaching plus or minus infinity tell you what happens at the end of these graphs. When we already saw on the right side in behavior that it's approaching 3 because there's a horizontal asymptote. But on the left side, as x approaches negative infinity, the outputs are tending towards positive infinity. So I know that this is part of my graph. Let's go ahead and tackle this one. So my outputs are tending towards -2 as my inputs are tending towards 5. And I know it has to tend towards 5 on the left and right side of 5 since the limit is defined as just approaching 5. Also, you'll notice that my function already has an output at x is equal to 5. So I need to make this guy an open circle so that I'm actually graphing a function. I also want to put little pieces of my function connecting to my hole in order for this limit to work out. Last, we'll go to these guys. So as my function values, as the outputs tend to -5, my inputs are tending towards 0 from the left-hand side. Again, we're running into the same problem where I have to make this a hole because x is equal to 0 is already defined at 8. So it's approaching -5 from the left-hand side, so I need to make sure that it's connecting on this side, the left-hand side of 0. And then on the right-hand side of 0, it's approaching 0. So I need this piece to be in my function. Now all I need to do is I need to connect this in a way that makes it a function. Sometimes this can seem kind of hard because there's so many options. There's infinitely many functions that we can draw of this kind. We just need to make sure that the conditions that we have drawn are satisfied. So I'll go ahead and connect these two pieces. As I'm connecting, sometimes it feels weird to draw your function so that it crosses a horizontal asymptote. In high school, you normally think that that's a no-no, or you're normally taught that that's a no-no. But in actuality, whenever you look at the definition of horizontal asymptote, it just means that, whenever you're close to the origin, meaning you're not going to plus or minus infinity, it can't cross the horizontal asymptote. So here is fine. So next, I'll connect this guy to this piece, this guy to this piece, and then I'll choose the lower one here. And then I'll make sure to get rid of this one because you want to actually graph a function. So once you're done, you need to make sure that you have graphed a function or graph something that passes the vertical line test, making it an actual function. Awesome. I also want to go through one more example of this table. And notice whenever you're doing this, you can make A and L any number you want. So I'll go through one more example with you guys. Notice I made a in this example 0, right? So here you can see there's a vertical asymptote at x is equal to 0 because as we're getting closer and closer to 0 from the right and closer to 0 from the left, my outputs are shooting up to positive infinity. Let's try another example. Say here. So what you'll do is you'll just sketch a function. And what's easiest for me is to go ahead and write what I want my a to be and what I want my L to be. Let's say 5. So here's a graph of a function to where my outputs are tending towards 5 as my inputs are tending towards 1. So I just need to write in words what this means. So if f of x tends towards 5, as x tends towards 1, then the outputs around x is equal to 1 are around x is equal to 5. Sometimes that means that there's a hole there, or there could be a removable discontinuity. But you could also define your function at this point. Just because you have a limit approaching L as x approaches a, that doesn't mean that that is undefined at f of a. But there is a possibility for that. This limit just talks about what the outputs are around x is equal to a, or in this case, x is equal to 1. So hopefully this has helped get you to start thinking about the big picture of limits, and good luck finishing your concept activity.